So now this video is purely for IGCSE students, and don't worry, iske baad your space physics will also be over. And this just talks about some more concepts. Now remember that in the last video we were talking about the idea of the expanding universe, and we talked about redshift as one of the pieces of evidence which tells us that the universe is expanding. Another piece of evidence that does tell us that the universe is expanding is known as CMBR. So this stands for cosmic microwave background radiation. So background radiation का word तो आपने बहुत ज़्यादा सुना है in nuclear physics. This is pretty similar to that. Instead ये कोई alpha या beta या gamma particles नहीं है, rather these are microwaves. So how did we even get around to discovering these waves? Exactly like जैसे मैं और आप अगर हम लोगों ने गाड़ी में रेडियो पे कोई स्टेशन सुनना होता है, how we tune into a certain frequency, वैसे ही in the 1950s there were these two scientists who were also tuning into a certain frequency when they picked up a background hiss. जैसे कि अगर हम लोग एक चैनल से दूसरे के दरमियान जब होते हैं when we are between stations, so we hear that static. So this background hiss was picked up by all the antenna, और चाहे ये किसी भी पोजीशंस पे जाता, आपको हर जगह मोर और लेस सेम ही अमाउंट ऑफ हिस मिल रहा था. This is what we call the CMBR or the cosmic microwave background radiation. और इसका source of origin क्या है? हम लोगों ने last time expanding universe and the idea of the Big Bang, both of these we tied together. We saw कि एक का दूसरे से कैसे link है. So what we understand of this right now is we say that जब Big Bang हुआ था, so Big Bang की वजह से जो radiation produce हुआ था, which is still around nowadays, वो जिस शक्ल में है अब, this is the CMBR. So the CMBR is a certain specific frequency. चाहे आप कहीं से भी ये माइक्रोवेव सिग्नल्स जो आप पिकअप कर रहे हो, इनका फ्रीक्वेंसी इज़ द सेम. एंड अदर देन दैट, अगर हम लोग इसके एम्पलीट्यूड के हिसाब से बात करें, another term which is pretty closely linked to the amplitude is in technical terms called intensity. So in the entire universe, it has the same intensity, चाहे आप कहीं पर भी चले जाएं. So this is the same intensity in all directions. CMBR को we have imaged this using different telescopes, and this idea we've confirmed using those images that we've obtained. So the CMBR is observed in any point in space. So this is an image that has been captured by telescopes which show कि कहाँ पे आपके पास radiation ज़्यादा है, कहाँ पे थोड़ी कम है. But remember that it has the same, it has a very specific frequency, and it also has the same intensity in all directions. अब इसके लिए there is another argument that यहाँ पे जहाँ पे जो red spots हैं, जहाँ ये CMBR ज़्यादा detect हुई है, तो this could probably be like a spot where more galaxies in the future may spring from. लेकिन this is just extra information, you don't really need to know this. तो खैर एक चीज़ जो आपको पता होनी चाहिए वो ये है that right now this is microwave, right? तो ये microwave region में है, तो इसकी microwave वाली wavelengths हैं. लेकिन जब ये शुरू हुआ था, when the universe basically started out, it wasn't always microwaves. इसका proof ये है, and this couples back with redshift, is that we know redshift has basically caused a longer wavelength. Redshift का मतलब ही ये होता है. So what we end up concluding is that the CMBR produced from the Big Bang must have had a shorter wavelength. So shayad pehle maybe this was not a microwave, maybe this was like a gamma wave maybe. So must have had a shorter wavelength. And then as time went on, then this radiation, you can say, redshifted, or you can also say this कि इसका सिर्फ wavelength बढ़ गया. और आपको पता है larger wavelengths की जगह, you can also say that the frequency of this radiation decreases. So इसका मतलब ये भी हो सकता है that maybe like many years from now, जब अब ये microwave में है, then maybe it could have become an even longer wavelength. शायद वो radio wave बन जाए. सही है? So this is because of the expanding universe, obviously. Acha ji. So now let's go on to the other thing that we have to talk about, which was Hubble's law. So right now expanding universe की अच्छी खासी बात हो गई है, but the key question you should be asking yourselves at this point is that how do we actually measure कि हमारा universe कितना expand हो चुका है या कितनी तेज़ी से expand हो रहा है. So हम लोगों ने expanding universe में we've talked a lot about the idea of the redshift. So if we look at a star and the light that we receive from that star, we can calculate how much redshift has happened. So basically, by using the amount of redshift, वो क्या है कि आपका जो wavelength है वो कितने से change हुआ है, या ये कि आपका frequency कितने से change हुआ है, both of these mean the same thing. I can estimate the velocity of recession of the star or galaxy. So we can find this out. इसका एक complicated सा formula है which basically works on the idea of Doppler effect, but we can find this out. इसी तरीके से exactly the same way we can also estimate how far a certain galaxy is away from us at Earth. This is done using a slightly different method, which is using the brightness of a supernova in that galaxy. So supernova की हम लोग पहले से बात कर चुके हैं. So what is a supernova? Which is the death of a high mass star, और उससे जो brightness जो धमाका होता है, by capturing the brightness we can also find out that how far away is this supernova or how far away that galaxy is from us. Using that we can find the distance of this receding galaxy from us at Earth. So distance भी आ गया और आपके पास उसका velocity भी आ गया. अब यहाँ पे पहले हम लोगों ने कुछ ये बात की थी that the further away galaxies are also receding faster. This was actually given to us by a scientist by the name of Hubble, and he discussed exactly this. He said that how fast a galaxy is receding from us is directly proportional to the distance that we are away from this galaxy. And then to make this proportionality relationship a proper equation, we multiply by this constant h0 or h0, which is known as the Hubble constant. Often आपसे एग्जाम में Hubble constant का definition पूछा जाएगा, and for that you can just rearrange this equation. If you rearrange this equation and make h0 the subject, this is v over d. And now you just need to put this into words. But with proper attention to what each of these terms stand for. So you will say that the Hubble constant, what is this? So you are going to say this is the ratio of, numerator में क्या है? V. So V was the speed of recession of this galaxy. So you will say the ratio of the speed. If you don't like the word recession, you can also just say the ratio of speed of the galaxy away from the Earth. So Earth से कितनी तेजी से move कर रहा है, and it's divided by the distance. So the ratio of this to the distance of the galaxy from the Earth. This is the definition of the Hubble constant. So यहाँ पे अगर आप इसको देखें तो usually we are used to seeing V as d over t. यहाँ तो कुछ multiply हो रहा है. So if you look at this, this is meter per second divided by second. So the units of h naught, unit of h naught is 1 over the unit of time. So इसके unit होते हैं second minus 1 भी लिख सकते हैं, या आप 1 over second भी लिख सकते हैं, right? So you can write either this or this. This is known as per second. Also another thing to keep in mind because of this direct proportionality is this, कि आपसे कभी ये सवाल भी हो सकता है, maybe in MCQs, that आपको इस तरीके से ग्राफ दे दिया जाए, and let's say you are told that on this graph maybe V is on the y-axis, so the speed at which the galaxy is moving away, distance of this galaxy from the Earth is on the x-axis, और आपसे पूछा जाए कि भाई इसका ग्राफ कैसे होगा. So you know that for all direct proportions, the graph is a straight line through the origin. So yeah, and then you can also see that because this is on your y, this is on your x, so the gradient of this graph would be the Hubble constant. आज तक ऐसा सवाल नहीं आया, but just in case. All right. At the time being, the best estimate that we have for h naught is this. So h naught a constant है, right? So it's going to have the same value all the time per second. Now again, this idea we can also tie in back to the idea of the Big Bang theory. Because if we think about the equation, which was this one, V equals h naught d, so मुझे ये पता है that they are moving at this speed, and I also know the distance at which they are, the distance they are from Earth at this moment. I can take this back in time. अगर मैं कहूँ Big Bang theory के हिसाब से, if everything was actually at one point, and if it started to move out at this speed, so how much time will it take to cover this distance? So yeah, let's talk about this now. So I can say that if a galaxy is moving out at some speed v, and right now if it is at a distance d from the Earth, so I can find out the time it took to get to that point. All right. So यहाँ पे अगर मैं equation को rearrange करूँ, I can say t equals to d over v. All right. Now ऊपर, when we were talking about Hubble constant, we know that v over d is h naught. We have the reciprocal of that here. So d over v is 1 over h naught. Now what is this time really? ये time क्या है? We just said that all matter began from a one single point in the universe. और अभी हमने क्या निकाला है? हमने निकाला है that as of now, how much time has been taken for that one particular galaxy जिसका मुझे speed पता है, और मुझे पता है कि अब वो उस point से किस distance पे पहुंच चुका है. So isn't this really just the age of the universe? Because if I take it back in time, by whatever this is, ये वो पॉइंट हो जाएगा जहां पे वो अभी एक मैटर सारा मैटर एक पॉइंट पे था. बट नाउ व्हेन इट इज एट ए डिस्टेंस d from us, if it is at a certain speed v, then 1 over h naught is really just the age of the universe. So a pretty amazing realization at this point. This is nothing but the age of the universe. So then if we try to do this actually, if I want to find the age of the universe, I would do 1 over h naught. उसकी value ऊपर दी हुई थी 2.2 into 10 to the negative 18. So this will turn out to be 4.54 into 10 to the 17. Because this was in per seconds, this is going to be in seconds. And this is, by the way, a huge number. Maybe आप लोगों को standard form में numbers को इतनी देखने की आदत नहीं है, so you might think this is like a pretty normal number. This is a huge number. To convert this into years, याद करें that in one of our very first videos मैंने ये conversion बताई थी आप लोगों को. So this each year has 3.2 into 10 to the 7 seconds per year. So when you divide this, you get approximately 14 billion years. This is the age of the universe, the most accurate estimate that we have of now. So that's all then, folks. That's the end of space physics in all its entirety. Hope you guys had fun. Hope you guys learned something. Check out the other videos that are there as well. And do like and subscribe to the channel. And if you have any suggestions for the videos, you can also let us know in comments. Thank you, and until next time. Bye.